Have you ever stopped to wonder how a massive AI, something like GPT-4, goes from just reading plain text to writing poetry or even code? Well, the secret isn't some kind of magic. It's actually a hidden language, a crucial translation step that happens way before any of the real thinking even starts. So today, we're going to dive deep into the incredible world of tokenizers.
So let's just ask the big question right up front. When you feed a sentence to an AI, how does it actually see it? Because it's definitely not with letters and words the way you and I do. And this is the core puzzle we're going to solve today. And trust me, the answer reveals a really fundamental truth about how these systems work.
And that answer really starts by understanding this one key concept, what I like to call the AI language barrier. There's just this massive gap between how we talk and how computers, crunch data.
See, on one hand, you've got human language. It's messy, it's full of nuance, context, sarcasm, you name it. And on the other hand, you have the language of machines. And for them, it's all about numbers. To a computer, a simple phrase like, "Hello world," is just a string of numbers. They don't see words. They literally just see math.
So how in the world do we bridge that gap? Well, that's where the hero of our story comes in, the tokenizer. Think of it as the essential translator, the one piece of the puzzle that takes our beautiful, complicated language and turns it into clean, structured numbers or tokens that an AI can finally understand and work with.
All right, so now that we know what a tokenizer is, let's pull back the curtain a little bit and see exactly how this whole translation process happens. It's actually way more elegant than you might think. I absolutely love this analogy. A tokenizer is like a specialist chef, a mise en place expert for the AI. It's meticulously chalking, sorting, and prepping all the raw text ingredients. It's making sure that the main chef, the AI model itself, has these perfectly prepared components to create a masterpiece. The whole process really boils down to 3 steps. First, you start with the raw text, right? Second, you break that text into smaller pieces, and these are what we call tokens. Now, this could be whole words or parts of words or even single characters. And finally, for each of those little pieces, it looks it up in a vocabulary and assigns it a unique number. Simple, right? But there's a really crucial detail we can't miss.
You see, a really good tokenizer has a fantastic memory. It doesn't just shred the text into a pile of numbers and then forget about the original sentence. No way. It remembers exactly where every single piece came from, and this is absolutely critical for understanding context.
And this memory system has a name: offsets. The easiest way to think about offsets is like a little GPS coordinate for every single token. It maps it right back to its exact starting and ending spot in the original sentence. This lets the AI know not just what was said, but where it was said in the conversation, which, as you can imagine, is just everything when it comes to context.
But, and this is where it gets really interesting, it turns out there isn't just one single recipe for tokenization. Different AI models use different chefs, and each one has its own unique style of chopping up text.
So let's just take a quick look at 3 of the most popular methods. You've got BPE, which stands for byte pair encoding. It starts with individual letters and then merges the most common pairs together. Then there's WordPiece, which is fantastic at splitting up words it's never seen before into smaller, familiar chunks. And finally, you have Unigram, which kind of does the opposite. It starts with a huge vocabulary and then intelligently trims it down. Each one has its own unique strengths.
Now, I know what you might be thinking. This all sounds super complex, right? Something that's only for the big AI labs. But here's the really exciting part. You do not have to stay on the sidelines. You can actually build one of these yourself.
Seriously, thanks to some incredible open source tools out there, especially the Tokenizers library from Hugging Face, this power is now accessible to pretty much everyone. You're no longer just a spectator watching all this happen, you can actually be a participant. I think the best way to think about it is like having a set of Lego blocks. These libraries, they give you all the fundamental components, the different algorithms we talked about, the pre-processing rules, and you get to snap them together to build a custom tokenizer that's perfectly suited for whatever you're trying to do. So when you learn how to use these tools, you're gaining real practical skills. I mean, imagine being able to train a brand new tokenizer from scratch, really getting a handle on those all-important offsets, mixing and matching components, and then plugging your creation directly into powerful AI frameworks. You really get to be the architect.
Okay, so we've covered a lot of ground. We've seen what a tokenizer is, how it works, and even how you can build one. But let's zoom out for a second. Why should you really care about this, what seems like a pretty small technical step?
Because it's the absolute first gate that all information has to pass through.
It is the AI's very first impression of our language. Before any of the fancy algorithms run, before any insight is ever generated, the tokenizer has to do its job, and it has to do it well.
I mean, just look at it. It's the foundation of the entire AI pipeline. All the raw text in the world flows in, but nothing, absolutely nothing, happens until the tokenizer converts it into numbers. Only then can the main model start to process it and, eventually, hopefully, produce something useful. It is an unskippable, foundational step.
It is step number one, period. And the decisions that get made right here, how to split words, what kind of vocabulary to use, they create this huge ripple effect that impacts everything that follows. A bad tokenization job can handicap even the most powerful AI model right from the start.
And this is why getting a handle on tokenization isn't just a technical exercise. It's really about shaping an AI's initial perception of reality. To control the tokenizer is to define the very lens through which your model will first see and interpret all of human language.
Which leaves us with a pretty fascinating final thought to chew on. If the tokenizer is the gatekeeper of information, the one that frames how an AI even reads our words, to what extent are we then shaping how it ultimately thinks? It's a powerful question to consider. Thanks so much for joining me.